Hello, this is Caleb Kovac with Benjamin Kelly and Evan Wyvage with the rectified circuit with smoothing capacitor with Zener voltage regulator powering a 555 timer and a light bulb. This is the our transformer with the AC and DC side with the 4 diodes going through our 470 capacitor with its in series resistors through the Zener diode, which loops back through, which then also loops through our 555 timer with a 1K, 10K, and a 470 again capacitor that causes our little light bulb to blink.
Alrighty, going over our 2 calculations we did. Going over the first one was the resistance needed in series to allow the Zener diode to work. So this specific Zener diode has a voltage of 6.8 volts. And we know that the rectified voltage coming out of our rectifier is 24 volts DC. Well, that would push through the Zener diode and it wouldn't let it to work properly in order to power a DC load such as the 555 timer. Well, in order to calculate that resistance in series with the Zener diode, you take the 24 volts DC minus the 6.8 volts DC of the Zener diode, and you're left with 17.2 volts that needs to be canceled out through the series resistance. Well, in order to find that specific resistance, you have to divide that voltage by the current flowing through the series resistance. So that'll be 11.8 milliamps. So 17.2 volts divided by 11.8 milliamps gives you 1,457 ohms. We don't have a 1,457 ohm resistor, so we had to do a combination of 1.2K, 100, 147, and a 10. Okay, now going over the second calculation was the needed watt rating of the resistors in series with the Zener diode. We know that power is equal to voltage times resistance. In this case, we don't have the voltage, so voltage can also be current times resistance because of Ohm's law. So it's current times resistance times current, which ends up equaling resistance times current squared. So you take that 1457 ohms found in the previous calculation, multiply that by 11.8 milliamps squared, and you get 203 milliwatts. Well, our resistors are a quarter watt, which is 0.250 watts, or 250 milliwatts. So the watt rating of resistors is no problem.
So our transformers bring in power into the diodes transfer the power to the capacitor runs through our resistors like Ben explained for our Zener diode so we don't overload it. After it gets to the Zener diode, it comes back into basically a 555 series timer where we have our resistors set up for the LED light. We were finding a 510 resistor, that's the resistance we needed. We didn't have a 500, so we had to come up with 2 1Ks in parallel just to make sure we fit that 510 radius for our LED light. We also have another capacitor down here storing the charge and letting the charge go so we could have that LED flicker.